Greetings everyone, my name is Gani Amri Rabbani, an undergraduate engineering student at the University of Al-Azhar, Indonesia. Recently, doing an internship at PT Inka as a research and development engineer. Right now, I'm doing a presentation with the title of Computational Design and Performance Analysis of Electric Vehicle Prototype at PT Inka, an Indonesia future plan for green energy and electric mobility through G20 presidency of Indonesia. Just a quick CV from me. I have an interest in control system, computer science, semiconductor, electric vehicle, renewable energy, and public transport. Okay, back to the topic. How the background of this internship? Well, the government of Republic of Indonesia has been appointed to hosting a G20 summit at 2022. And because of that, also the government create a consortium between Ministry of State-Owned Enterprise, Ministry of Transportation, Ministry of Education, and BRIN, alongside with the national university around Indonesia. So, the objective of this consortium for the development of electric bus for G20 summit in Nusa Dua, Bali with TKDN expected to above 40%. PT Inka, as a manufacturer for railways, also has an interest to develop an electric bus. Then, PT Inka leading the project for producing 42 units of large and medium electric bus for G20 Indonesia. Here is the component supplier for Merah Putih electric bus. As we know before that Indonesia has expected with TKDN above 40% for this project. So, in order to achieve that goal, PT Inka try to encourage a local supplier to supply their products to be in band, to be produced, to create an electric bus. So the local supplier for this electric bus are coming from Krakatau Steel, Barata Indonesia, PT Pindad, PT Land, ABC Battery, and NSAD. Also, we still do have an import for other components. So the foreign suppliers are including Texas Instruments from USA, ST Microelectronics from Europe, BYD and Zhangtang from China. Here's the potential vehicle operator of Merah Putih electric bus. So, around 53 units of electric buses produced by PT Inka are going to be delivered to its customers. And the customers for this electric bus are Damri, Transjakarta, Angkasa Pura, Bluebird, and Mayasari Bhakti. 9 units of it will be owned by Dikti. So the only vehicle operators that has been confirmed to own and operating this vehicle is Damri, as Damri also operating for transporting the delegates of G20 summit in Bali. And And the rest of its potential customer, as it is right now, are in discussion. Here is the specification for Merah Putih electric bus. This electric bus is embedded with a lithium ferrophosphate battery with the capacity around 138 kilowatt hour. Also, this vehicle has a motor, permanent magnet synchronous motor with maximum power around 220 kilowatts. The battery charger for this vehicle also produced by PT Inka with the input voltage of 380 volt AC, 3-phase AC input with the maximum output power around 120 kilowatt DC output. Here is the software requirement for developing electric vehicle at PT Inka. Electric vehicle, not only electric, also in the wide concept of engineering that that vehicle is a complex system which is require a lot of understanding in mechatronics. So we are using a lot of software to develop this electric bus. Here's the electric bus body frame and chassis. So this electric bus using a semi-monocoque as the type of the chassis. The chassis material using stainless steel and the frame material using also stainless steel. The reason Inca uses stainless steel as the main chassis and body frame material is because stainless steel is corrosion resistant, have the high tensile strength, easy formability and fabrication, low maintenance costs, and environmentally friendly. Here's the illustration of assembly process from chassis to the car body. Okay, here is the complex system of electric vehicle. I know it is a complex system, but in order to have the understanding of this complex system, we have to focus on each line. This each line, I'm going to explaining it. So, we're focusing first on the dark blue line. The dark blue line represents a high power, high voltage power cable. So when the charging from DC port charger, the energy flows to the PDU, which is power distribution unit, from PDU to the battery. When the vehicle is turned on and begin to accelerate, the energy from battery then discharged to the PDU, from PDU to the inverter to convert DC power to AC power. And then those AC power began to feed the energy to the permanent magnet synchronous motor. The motors convert electrical energy to the mechanical energy, in which this energy delivered to the wheels. The wheels generate an inertia. So the electric vehicle, this electric bus also has a curve which stands for kinetic energy recovery system. from regenerative braking to store its energy back to the battery. Auxiliary inverter has a role to split the energy from DC high power dark blue line to the AC high power to AC low power and DC low power. The low voltage power cable represent in light blue line. And then the battery pack and electric motor generate heat when turned on and operating. So to regulate the heat and prevent a system failure from overheating, the liquid cooling system is installed. The fluid properties is represent the cooling system of the system. And then the data cable, the green line, is a communication protocol between microcontroller named CAN, the controller area network. There are many types of CAN protocol from Society of Automotive Engineers. As this vehicle is characterized as a heavy-duty vehicle, this electric bus using SAE G1939 CAN protocol. So the vehicle control unit is also as an alias as the brain of this vehicle, because vehicle control unit controlling all of the subsystem from microcontroller of each subsystems. Next is the advanced driver assistance system. So what is the ADAS? ADAS is the driving assistance or driving automation that has 6 levels, that also has a standardized from SAE, which the protocol of SAE G3016. So Merah Putih electric bus is using ADAS SAE level 1, whereas the vehicle is embedded with ultrasonic parking sensors, anti-lock braking system, emergency braking assist, cruise control, surround camera, and GPS. Also, for your info, that the Tesla electric vehicle, so many experts say that Tesla autopilot at the level 2 of driving automation. And some experts also say that they are on the level 3. So it's still in the debate for Tesla autopilot, which level of those vehicles are in. Okay, next is ADAS block diagram of Merah Putih electric bus. So it is the simplified diagram of ADAS, which is the camera system. It has a camera, video encoding, the power input from battery, the memory, the main microcontroller TDA2X, and the CAN communication protocol. So when the image captured from the video is being processed on the encoding, and then delivering it data to the microcontroller. From the microcontroller, the output of this data then to the heads-up display from the LED display at the at the cockpit of the electric bus. Here's the vehicle performance analysis that are performed using MATLAB to find attractive effort of the vehicle and analyze how well performed the vehicle torque for climbing the hill at the different slope angle. So here is a simple equation that required to calculate the tractive efforts. There are aerodynamic resistance, rolling resistance, gradient resistance, and motor torque and wheel torque. So here is the analysis results. There are two graphs here. Left side of the graph is a motor torque and the right side is the wheel torque. We can see the difference between both of them, that the wheel torque has a higher torque than motor torque. Why? Because the torque from the motors is amplified by the gearbox to the propeller shaft and then to differential, which is why the torque from the motor is lower than a wheel torque. Here's the tractive effort graph. How do we comprehend this graph? Well, let's focus on the traction hyperbola here in the green line. Every line that intersects with traction hyperbola in every degree of road gradient, that is where the maximum torque ability of the electric bus accelerate at every gradient angle of the road. For example, when the vehicle is 20 kilometers an hour in speed, the torques generate around 15,000 Newton meter. So around those 15,000 Newton meters, the vehicle able to climb the hills around 10 degrees of gradient slope angle. When the higher of the torque, the higher the torque, the higher also the gradient slope resistance that the vehicle able to climb. Okay, now G20 Summit as a global forum for the movement toward socio-economic and technological sustainability. G20 member states through the forum of G20 Indonesia, namely B20 for business, S20 for science, and T20 for teen, are in discussion to going into a green energy transition through renewable energy, energy storage system, electric vehicle, public transportation, carbon market, and financial support through investment for tackling the ongoing climate change. Many companies from diverse sectors like finance, automotive, electronics, energy, and digital technology are also in the participation for this forum. United States of America signed a massive 20 billion investment for Indonesia's effort to energy transition and sustainability. So, the government funding of $20 billion is likely to include concessional loans, grants, and equity. Details of the financial package are to be developed over the next 3 to 6 months, with the funding split between government and private finance. Indonesia will commit to capping carbon dioxide emissions from its electricity at 290 megatons by 2030. Indonesia also established a goal for its net zero emission in the power sector by 2050 and commit to boost deployment of renewable energy comprises at least 34% of all power generation by the end of this decade. It is also the largest single climate finance transaction ever made, according to a senior US Treasury Department official. So, how the electric vehicle business potential in the world? Well, based on the report from International Energy Association stated on this graph that global EV market predicted to be growing exponentially based on these three scenarios from 2021 to 2030. How big is the potential for Indonesia on the business and the market for electric vehicle? Well, the potential is huge. Why? Because because Indonesia has the largest production and reserve for nickel, and also Indonesia has plenty of a cobalt reserve. For nickel especially, that production of the nickel itself from Indonesia around 40%. That is a huge number for Indonesia than compared to the other countries. How is Indonesia's role in EV supply chain in reality? Well, unfortunately, China is dominating the EV supply chain. And it sucks because Indonesia only has a role in mining and material processing. Indonesia don't process the class 1 nickel, which is the class of nickel that capable of storing energy as a battery chemical. As it is right now, even Indonesia only capable to processing the class 2 of nickel. But the government has a plan to producing a class 1 nickel locally that the Ministry of State-owned Enterprise has been announced of the founding of a new company, a state-owned company named Indonesia Battery Corporation or IBC. So IBC, after its founding, has been received an investment from LG Energy Solution with the value of $9.8 billion and also received an investment from Hyundai to build a factory in Indonesia, which is it is a huge effort from now on for the government of Republic of Indonesia that they have been serious for to take this opportunity to green energy transition. And now, how do we create the EV ecosystem? So, the EV ecosystem consists of wired and wireless charging station, portable home onboard charger, battery swap station, and funds electricity grid for supporting EV charging with renewable energies like smart grid and microgrid. IoT are also be the main player for building the EV ecosystem, especially for self-driving EV that connected with smart city infrastructure through big data and artificial intelligence. investment for advancing battery technology also important for faster charging, increased safety, and larger energy density. Financing other EV supporting sector like power generation and electricity grid also improving the creation of EV ecosystem. Here is the comparison between the computer design and actual design of Merah Putih electric bus. This is internship documentation from me. As you can see on the center below of the image is it is me, and on the upper right of the image is the executive director of PT Inka alongside with Ministry of Defense Prabowo Subianto. Here is the G20 summit documentation. That on this image is this electric bus has taken a photos with a US Air Force aircraft in the Ngurah Rai International Airport at G20 summit. And also here's a quick video explanation from Eric Thohir Instagram video demonstrating Inka electric bus on action.
Sekarang kita akan naik bis listrik ini buatan Indonesia sebagai akses kemudahan untuk fasilitas publik yang ikut G20. Ayo.
Okay, next is after G20 summit, these electric bus are changing the role for public transportation at different cities in Indonesia, especially in Surabaya, Bandung, and Jakarta. Now we'll reach the conclusion. So, Merah Putih electric bus internship at PT Inka is a huge success for us Indonesia to show to the world through G20 summit that we are committed for going to green energy transition and take this opportunity for human development of future engineers at Indonesia that involved in this project. Mr. Nadim's vision as Ministry of Education to create a collaboration between education, research, and industry through Campus Merdeka is reflected by this project to develop an electric bus with collaboration between national universities, researchers, students, and manufacturers. Also, Elon Musk has been in discussion with Ministry of Education Mr. Nadiem Makarim at Campus Merdeka Festival of G20 Summit has said that Indonesia needs high-speed internet, critical thinking and education, and establish a relevance between education and industry. So, thank you for watching this video. I hope you will informed from watching this video, especially in the international relation, international business, international supply chain, and a recent development of electric vehicle in Indonesia and also in the world. Thank you and goodbye.